Hello everyone. Welcome to this session on introduction to Docker and Kubernetes. I have with us Mohit Chabra, who is 6 times Microsoft Valuable Professional and Microsoft Certified Trainer. He is currently working as a Cloud Operation Manager at uh, Configit. I hope I'm not pronouncing it wrong. Configit. And welcome Mohit. Welcome everyone. Welcome to this session on introduction to Docker and Kubernetes.
Thanks, Chaitanya. Thanks for the quick introduction. I would just like to make a quick summary about myself and then some of the changes that you have told about me. So let me share my screen first. I hope my screen is visible to everyone. So, a little bit about me. As Chaitanya mentioned, I'm a Microsoft MVP from last 6 years, and the role of an MVP is it's called Most Valuable Professional. It's an award given by Microsoft to individuals who have been a community leader for quite some time, and they have been able to impact the audience in some way or another. So I've been fortunate enough to say that I've been awarded from last 6 years in this category, and I've been awarded specifically for Azure. So anything related to cloud is where I work on. So my career has been mostly on Azure throughout my journey. I started 10, 11 years back when Azure was quite new, and here I am right now. Um, when we started, there was cloud native services, and now the world has moved to something called Kubernetes, which is more native to the cloud, which is independent of any cloud vendor. So you can use Kubernetes on any other solution, whether it's Azure, AWS, GCP, Alibaba, so on and so forth, or your on-premises setups as well. So we are trying to speak a common language all across these different platforms. And I'm going to come on to that as well in a while. Talking about my roles, so currently I'm working as a cloud operations manager at Configit. We at Configit are responsible for some of the biggest manufacturing industries runtime. The idea is that if you are if you have any configuration program, we basically help you out in solving that program. So, for example, if you have Tata, for example, Tata is manufacturing a car, and you go to a showroom and then you want to buy a car. You can do so many permutation and combination. You can choose on what exactly do you need in your car, whether you need alloy wheels, whether you need leather seats, so on and so forth. Like you can say that I need this model with this CC of engine. So it's a permutation and combination configuration program that we basically solve with our engine. So it's a product-based company, and we try to make sure that we solve these configuration logistics underneath for our customers. And my role is to manage SaaS. We make sure that in my team, in my department, that the application is up and running 24/7, and it's available, it's performing, and it's secure at the same time. So the reason I'm giving you this background is because it's very important throughout the whole journey that I'm going to talk about in the next 1 hour or so. Um, I want to give you this background because I also wanted to share with you that this is not the first role that I've been doing as operations. So I'm right now heading an operations department, but when I started as a developer. So I've seen the both of the phases of an industry. Traditionally, there has been a lot of fights between the developer and operations, and that's how the whole DevOps methodology came into the picture. But before we go into that, the traditional fight has been that the developer used to code in their local machine, and then they say they release that code out, and operations guys used to basically pick up that code and deploy it on the server, and then boom. All of a sudden we identifies that okay, something is not working, something is wrong, there are some issues. So from that perspective, that's always been one of the biggest challenge from developer versus operations fight that we have traditionally. So what used to happen was operations used to say that it's not working on the server, but developer used to say that okay, it's working on my machine. I, I'm I'm hopeful that you might have heard this statement by now. So it's working on my machine. Operations used to say that, okay, it's working on your machine, but we cannot ship your machine to the client. And like, I don't know what's happening. Developer was curious because when they were trying to reproduce the issue, it wasn't reproducing into their machine, and everything was smooth. So what used to happen was there was some configuration, some dependencies that people might have as part of their development setup. For example, I've been mostly working with the .NET and Microsoft technology, so I will use that example, but it holds true for anything and everything going forward. So if I have, let's say, Visual Studio installed in my machine, it also installs some of the dependencies. For example, .NET Framework is installed. Now, if that .NET Framework is not updated on the server, then the application will not work on that server because that's a dependency for that application to work on that server. But often and not, we have seen that the developers did not identify those dependencies correctly because they have everything in the machine that they are coding on, and the gap was increasing because something like .NET Framework is obvious, but there will always be small libraries and dependencies that will be missing, and then it's very difficult to identify those gaps. And this has been traditionally a big challenge for the whole tech industry, for the whole IT industry. Um, so what happened is this methodology or ideology that people used to say from operations saying that, okay, we cannot ship your machine to the customer, but only if there is a way to ship that. Someone said, why not? Right? Do we actually need to ship that machine to the customer or the environment to the customer? And that's why the whole concept came in. Means we had this concept of containers from quite some while, but it became popular. The whole methodology around DevOps, where we wanted to make sure that developers and operations guys come together into one group and work together as one team so that the developers can identify the pain points of operations and operations can identify the methodologies that developers are using during their during their development process. So during the deployment process, there are no surprises. We want to understand, we want someone who can speak both of the language, whether it's the development or the operations. So the methodology around DevOps came into the picture, and that's why it became so popular in the last 10 years. But in the last 10 years to 15 years time frame, the concept of containerization also became very popular. So container in itself is a very old concept, but let me tell you what it is first before going into more details about how and when it became so popular. So containers are nothing but a lightweight alternative to virtual machine. What does it mean? It basically means that in the example that I was sharing with you, that we cannot share the developer's machine to the customer, but we can share the environment. So what is there in the environment? So the actual application that the developer has developed, the underneath libraries that we need, and they might have tested that application on a specific server, on a specific OS. So that OS itself. Do we actually need the actual virtual machines OS? The idea is no, but a layer of that OS which can be packaged together. So if you see from a traditional virtual machine, you were running on, let's say, a Windows OS, and then you had hypervisor on top of that. Then you had your guest OS. If you don't know what it means, so basically most of the people were using hyper virtualization, and then inside that you can um, you can create your own OS servers. So you had your guest OS over there, and then you had the libraries and the application on top of it. So from that perspective, you didn't need it this hypervisor and it's the host operating system because you only needed these libraries. these configurations, these dependencies that application has to run. So what we thought, okay, if there is a way to containerize or package the whole dependencies that you need into one shippable form. So that's what we did. We basically created something called as container and containerized that application with all the dependencies with something called as container engine, which can basically manage and package these things together uh, with the operating system that we have tested this application on. So the idea of a container is something that is a package unit into a shippable format. So I just saw a question, which operating systems are there in a container? That's a good question. I would say all. So you can choose what you want. So you can identify, let's say, if you want to run your application on Ubuntu, you can mention that you want to build on Ubuntu, and then you can deploy on Ubuntu. Um, I have a back throat, so I might be coughing throughout the session, so please bear with me. So then this concept of containers came into the market probably like 2025. I don't even remember what is the exact year it came out, but this container has been there since long. The whole concept of containerization has been there since long. But what happened that all of a sudden everyone started talking about containers. So it's been there since probably 90s, before even I started going to school. But when I started working after a few years, the whole concept around containerization and Docker and Kubernetes was a big hype. Um, so I was wondering what happened. So Docker happened. So Docker is a company which came into the market and commercialized this whole concept of containerization and streamlined the whole package scenario. So, so basically the whole idea is that Docker was able to containerize the whole setup into a shippable format. Now, I received a question, which is also a very vivid question, that wouldn't the containerization be storage intensive if a package whole OS into it? It's very vivid question. The idea is yes and no. For containers, we have a stream version of these packages. Also, at the same time, you might not need OS in all the you might not have to put the OS there in all these setups. And I will give you some example going forward, but the idea is the all overall containers are not very big. It's a small setup and you don't need a full-fledged OS system. You need an OS layer. And I will talk about how does that work at a later point of time before when we go into that layers concept. But talking back about Docker. So Docker basically is a company who popularized the whole concepts of Dockerization and containerization. So there are other companies as well who are doing containerization, but Docker is probably by far the leading open source platform that we have on the system. And the whole idea is that because we are using the whole concept of containerizing the environment that a developer has, so it does not matter. It does not matter where it is running, whether it's running in developer's laptop or it's running in Azure, AWS, GCP, Alibaba Cloud, Oracle Cloud, or your bare shell on-premises servers. Because we are configuring in a way that we are packaging the whole ecosystem that an application needs to run in, then we will are able to run that anywhere and everywhere without any dependency issue. So how does this work? How does this whole concept of Docker work? So you need to understand three basic concepts around Docker. And then if you understand this, your brain will be like, okay, now I understand what it's actually doing. So client, host, registry. Client is basically where you are. Um, so let's start with host probably. So we have something called a Docker daemon. Let's think of it as a Docker engine who's responsible for managing all the commands. So if I am running these commands from the client, my client can be my local machine, my client can be an AKS cluster, my client can be uh, a Kubernetes cluster in a Bayer shell. But the whole idea is this Docker host is basically responsible for running these commands onto an engine or a server. Um, what happens is that now you have, let's say, packaged the whole Docker image. So you need to store that image somewhere. So you basically created a container. This container is responsible for running a piece of software, and then you basically create an image out of it. The image basically is nothing but a workable unit of your multiple containers. If you don't understand this concept, I will give you some example going forward. So that's going to clarify it for you. But the whole idea is that container is a small unit for um, for one piece of software. For example, we were talking about OS. So OS layer can be one container in itself. Then on top of it, let's say we are running an Nginx server, that could be another container of it. But when you stack up all these containers to make sure that you have all the requirements to run a specific piece of code, that can be served as an image. Um, and that image basically needs to be created and then stored. I'm not sure about the experience level over here in this group, but think of it as GitHub. So when you create basically a piece of code, you also need um, you also need a consumable, a DLL or an EHC that can be consumed. So you basically build that code, right? Think of it that built code as image. Then you need GitHub to store that code as well. So it's a repository. So think of that repository as a registry. So when you create these images needs to be stored somewhere, right? The package that you're creating, the container package that you have in an image needs to be stored in a repository. Now, instead of it being a repository for code, it's a repository for your images. So there are different registries in the market. The most popular one is Docker Hub. Then you have a lot of private registries as well. So there is a concept of public registry and private registry. So the idea is that anything on the public registry is available online. For example, if I need .NET 8 as a runtime, or I need Python as a runtime, then I can go to Docker and all these companies basically has their own sorted out registries or all sorted out images on these registries or basically Docker, for example. So what you do is instead of creating your own container for .NET 8, let's say, you basically pull this .NET 8 image from Docker Hub. So because it has to be publicly available, it's in a public repository that anyone and everyone can pull without anyone and everyone can pull without any authentication or without paying for it. However, the piece of code that you are developing, you don't want to open source it. You don't want anyone else to consume it. It's your basically proprietary software. So you put it behind a private registry. The idea of a private registry is that it's behind an authentication mechanism, and someone needs to, or you have to authenticate in order to fetch that registry. So I received this question from Suzanne. It's registry and repository same. So think of registry as a repository for images. Like you had your GitHub repository for code. Now this is a repository for storing your images. Sorry. So how do you work with Docker then? So you work with Docker with uh, something called a Docker CLI. You can install it on your Windows, Linux OS, any operating system. It basically just work. It's a cross-platform utility that works across the different OS that you are running. But the idea is that you don't get an interface. You basically see it with Docker CLI. There are a lot of interface that we have right now from Docker itself and third-party interfaces as well. I'm going to show you Docker interface as well, but the best way of interacting is through CLI. How do you do that? So we have this methodology of running a Docker container. For example, it's one of the example that I have, but here, in order to interact with your Docker registry or Docker container, you use a keyword called Docker. So of course, you need to install Docker in that client machine. This client machine can be your local laptop in this scenario. What you're saying is one hyphen I hyphen T. So one is a verb stating that you need to run that container, and hyphen I hyphen T basically saying that you want to run this container with the interactive terminal so that you can interact with that container. Which container? You want to run Ubuntu. You want to run Ubuntu in this example. So what it's going to do, it's going to pull. This command is going to see whether you already have anything called Ubuntu in your local machine or not. If you don't have it, then it's going to search for Docker Hub, and it's going to download the Ubuntu image from Docker Hub. So first preference is always the local registry, which is in your local laptop, um, or basically the client machine. If it's not available there, then we basically fetch it out from the Docker Hub. Then if you want to put any command to execute in that container, you can put it afterwards. Or you can also then, because you're setting up an interactive, you can also talk to it at a later point of time. But if you just focus on the first three things, Docker is basically you're telling your command line to use the Docker CLI. Then, then run in this scenario is a command to run a Docker container, and then Ubuntu is a name of the container or image that you're pulling out from the Docker Hub or your local registry. So some of the common commands that we have for Docker. So Docker run. Docker run is used to run an image, as we just discussed. So Docker pull is, as the name suggests, it's used to pull. It's used to pull an image from the registry. So basically downloading that image into your client machine. Docker build is used to build a Docker image. So let's say in the previous examples, we were talking about the Docker architecture, right? Now you are creating that Docker image yourself where you want to have your all layers with, let's say, a .NET application. So you are building that layer of the image of the containers. And sorry. So you are basically building that image yourself, and you want that image to then be available somewhere. So you can then do Docker build for your building and Docker push for pushing that image to a container registry. Then you have Docker images. it gives you the list of available Docker images that you have. If you see Docker images, you will see the list of Docker images in your local machine or your client. So you can see what you already have downloaded or created. Let's say if you have built an image, you will see the built image over there. Or if you have downloaded, like in our previous example, we have downloaded this image from Ubuntu, the Ubuntu image from Docker Hub. So that will be also shown in this Docker image command. Then you have Docker PS. It will give you the list of all the running Docker containers. What does it mean? So there is a difference. One is that you have downloaded the Docker images in your local machine, but you might not be running all of them at the same time, right? So only the running images that you have, let's say you have developed an application with .NET Framework in it. So that application that you have built, so that basically is responsible over here, and that will be shown over here that it's a running Docker container. Then Docker execute is basically to execute a command within a container, and Docker stop is used to stop a running container. Then then we understood, okay, right, we have Docker container, sure, but we cannot package everything into one container or one image. Why is that? Um, so a few years back, the concept of microservice architecture became very popular. What was that? The idea of a microservice architecture was that you deploy individual services, you develop individual services instead of managing a one big monolith application, because that becomes very troublesome. And then whole concept of microservice architecture also popularized the whole concept of Docker and containerization, so on and so forth, and hence Kubernetes. But but the reason this whole concept became very popular in the back was that it allows us to manage and troubleshoot and deploy all these services individually. Let me take an example of it. So let's say Amazon.com. So Amazon.com, the e-commerce website that we have from Amazon. Now that's a very big application. Managing that big application is very troublesome. So, but there are thousands of engineers who are working in AWS and Amazon.com, but the whole idea is that if you have to ship something which is developed by thousands of people simultaneously, every team will be every team will have different timelines. They might not be able to release. So if you have one big application releases, the risk of something going wrong and then reverting back is also very high. And deploying that big chunk of code is also very challenging. So what we did is we said that every team is responsible for their own piece of code. What basically means is that, let's say, we have a team responsible for shipping API. So you see, when you order an item, you have a shipping API which is responsible to track your shipping. Another one is to add to cart API, who's responsible for adding any items to the cart. Another one is a product description team, which is responsible for managing the product description. When you click on it, you basically see all the product descriptions, so on and so forth. Now, um, in this example, it's not only the development, it's also deployment and scaling as well. So let's say the big billion day sale is coming. I'm not sure whether it's from Flipkart or Amazon, but let's just say a sale is coming. Amazon special sale, Diwali sale is coming. Now, during the sale, we all know that we expect more load on the system because more people will be coming to the application as compared to the normal days that we had in before the sale. So we need to make sure that we can scale to support that application. Now, scaling the whole application would be very challenging because it will be very resourceful. So it will need much more resources. And how much can you scale? Should you scale for 1 million users? What happened if 2 million came in or 1.5 million came in? Then, okay, should you scale for 2 million then? Okay, but what if you scaled for 2 million, but only zero point 0.5 million came in? Then you're wasting all the resources, right? So you basically design these things in a way that you're able to scale them independently and on demand. So the idea is that doing this sale, let's say, doing this sale, the add to cart API will be used more, where you're adding things to the cart. Product description API might be used more. Payment uh, API might be used more. But once the sale is over, do we need that kind of scale on these APIs? The answer is no. So we can scale them individually back. But after the sale is over, what you typically do, you track your package, right? So the tracking API will have more load on the system as compared to what we have on the add to cart or payment. Like it will still have some load, but the load will go right before the sale. It will be this doing the sale a peak, and then after the sale going down. Whereas on the tracking, before the sale high, after the sale, the peak API, there will be a peak on the tracking API, and then it will be again down, right? So you see that there is a different load patterns based on the different scenarios that you might have in your business. So there is no point of scaling the whole application Amazon.com because it's a very big application. It's going to consume a lot of resources, and resources are expensive, right? So basically, you efficiently scale it out, and then you want to make sure that you can deploy these individually as well. For example, the shipping API. Now this team has made some bug fixes, so they have added some new feature. We don't want to wait for all the other API teams to basically push this code out. We only wait to want to make sure that when the piece of code is ready from shipping API, we can ship it. And that's how we are using it as a microservice. Instead of one big major service, we have shipping as a microservice. Then then tracking is another microservice. Then add to cart is another microservice. Payment is another microservice, right? So all these are microservices, and it's handled by individual teams. So coming back to the whole container orchestration, now what happens is this team, this team that we have is able to this team that we have is able to deploy and scale these services manually. But it becomes very challenging to do these things manually because now you don't have one or two containers, you have hundreds and thousands of containers. So it does not scale very well. So these whole things become very challenging to orchestrate. The whole idea of orchestrator is someone telling some other things what to do and how to do it. So whether it's scaling, whether it's managing, deleting, no, scaling in the terms of scaling the number of containers. For example, in the example that we were using, that you want to scale the number of instances. For example, you want to make sure that 1.5 million people can be accommodated. So you need to have, let's say, 200 instances of this tracking API. But when the load comes back to 1 million or zero point 0.5 million, then you don't need 200 instances of tracking API. Maybe you can serve them with 100 instances only. Then why to pay for 200? So it's not the storage, it's the instances, the CPU and the memory use for running the application. You can scale it up and down individually. Um, I got this question from Bishar. Is it related to load balancing? So load balancing is a different concept, but it's similar. For example, The idea is load balancer makes sure that the traffic is going to the individual services. Um, but like for example, if you have 200 instances underneath and the traffic is coming to this load balancer first, this load balancer will be responsible for sending this traffic to the individual services, to the individual instances. What does orchestrator does is it makes sure that first of all, when you said you need 200 instances, there are 200 instances. Then it also responsible for sending this traffic as well. So I'm going to come into that when we talk about Kubernetes now. Um, Maybe it will answer your questions over there. Um, so we needed a piece of software to manage hundreds and thousands of containers underneath. And there are a lot of companies which came out and we which started talking about this containerization orchestration. And one of them was from Docker itself. It was called Docker Swarm. But there were another one for DCOS. But there was one company. There was one piece of software which is open source and managed by CNCF, the Cloud Native Foundation something. I don't remember the exact abbreviation, but it's an open source community basically, which came in and took over the whole concept of Kubernetes in their own hands. So this image is very important for you to understand that how does Kubernetes work. So you've been talking about shipping a container. So this container are your individual applications. These are your individual services. In our example, tracking API is one container, or it can be one image, and it has all the containers underneath to run that image. For example, if it's built in Python, so Python runtime and that piece of code. Now it might have Redis cache as well, so that cache is also part of that container. But now, because you have hundreds and thousands of containers, you cannot manage them individually at all. That's why you need an orchestrator, which is the engine over here. So you are sitting as the master of the ship here and running it on our infrastructure. So you see the ship is holding all these containers up. In our example, it's going to be Azure Kubernetes Services, AKS. It can be your GCP, AKS, or it can be the EKECK on AWS. But the ideology basically remains same, that your cloud infrastructure is holding all these images and it's managed and controlled through a master over here who knows how to handle this whole ship, who knows how to manage all these containers. So this master over here is the orchestrator, is Kubernetes. So how does Kubernetes work? So Kubernetes has this typical master slave or master worker architecture where the master tells the node on what you need to do. And the node basically is nothing but, I will come to that, but it's nothing but a virtual machine. So in master, you have something called as API server, which is, if I have to sum it out in a very simple language, a piece of software basically responsible for managing this server up. Then you have scheduler, which basically can schedule some jobs for you. There is etcd, which is responsible for storing your configuration details. And we have a controller manager, which can control and manage all these nodes with Kubernetes and Kubernetes proxy. So I will tell what is Kubernetes and Kubernetes proxy. So Kubernetes is basically nothing but a specific piece of software which is then deployed to these individual virtual machines, where Kubernetes master can tell on how do you want to work. For example, in my department, I manage a team. Because they are part of my team, they are not only part of my company, but they're part of my team. I can assign that some task to them. That So that authority is something called as Kubernetes. So basically, this piece of software is running in this worker node. Then this Kubernetes master is able to tell these worker nodes on what to do and how to do it. So there are some of the important features around Kubernetes. If you understood this part, it's okay. If you don't understood it completely, then it's also fine. Um, but I will come to a later state where you will basically be able to see what's happening. We're running out of time, so I will be a bit fast right now. I received a question, does Kubernetes run on top of Docker? The answer is yes. So when you have Docker is to manage the individual containers, but when you have hundreds and thousands of containers, then you need an orchestrator. If you have seen orchestra, you might have seen an orchestra. There is an orchestrator in orchestra where there are individual hundreds of musicians or tens and thousands of musicians. They all are playing their own instrument, but there is someone who's playing violin, there's someone who's playing drums, whatever, right? So there is a group of people playing their own instrument. So these instruments are nothing but these individual players are nothing but their own containers. But then there is one guy who is doing like this, who is orchestrating the whole orchestra on how to proceed, how to basically change the tune, how to generate and manage this music. That orchestrator who is doing like this, right? Some of you might be wondering that what exactly the role of that guy, but that guy is a controller. So all of these individual musicians are your individual Docker images, whereas that orchestrator is Kubernetes. So some of the benefits that we have on Kubernetes is you have container replication. We were talking about scaling up the systems, right? So we need 200 instances of containers. So from that perspective, the Kubernetes allows you to copy paste, copy paste, copy paste. You can simply say that I need 200 versions or 200 instances of a specific application, like the tracking API running at that point of time. So Kubernetes allows you to do that. What you have to do is just say replication 200, replica sets 200. That's it. And Kubernetes will make sure that there are 200 images created who can manage and load balance the system for you. Then then we have monitoring, of course, when you're running. I'm from operations background, so we need to make sure that we can operate in a way that we can monitor the systems and then have alerting and all those sort of those things. Then someone asked about load balancing. So load balancing is also a part of this Kubernetes. It's one of the features that Kubernetes has. For example, if I have two instances of an app running, so if one instance is busy, I cannot assign him more tasks, right? As a manager, if I'm the manager, if one of my employees is busy with another task, I will see that who has the flexibility, who has the bandwidth to take over the other task. So I will assign the task to the person who has more bandwidth. Same is the concept that Kubernetes does, that whomsoever is sitting idle or whomsoever has more bandwidth, if someone is busy, we don't send more traffic to that instance, we send traffic to someone who's sitting idle. So that's the whole concept of load balancing, and Kubernetes is smart enough to basically see to take that feedback from individual workers on whether you're busy or not. And it sends these traffic to these individual services. Then if these services are running, then someone has to tell this to Kubernetes as well, right? If a person is sick, if one of my team members is sick, then we need to make sure that that individual basically tells me that, sorry, I am sick and I cannot work now. Sorry. Um, so we cannot work now is something that a message came to me as a manager. Now, of course, if a person is not working, I cannot assign that work to that guy, right? That individual is out of office, he's not working. So I will assign it to someone else. So that is basically your health check. So Kubernetes keeps on asking these individual instances in the individual containers whether you're fine or not. And if you're not fine, you will not send the traffic to that sick container. That's the same ideology. Um, then you want to make sure that your employees, your individual containers are not consuming more resources than necessary. For example, if you're in the terms of employees, let's say if you have 100 GB data that you want to share it across your employees, um, you don't want that one employee to consume 50 GB and then rest 10 of the employees basically are consuming 50 within themselves. Maybe that one employee might have to consume 50 GB because he's doing some task. And then you know about it. And then you basically allow that employee to use 50 GB of data. But what if you wanted to equi-distribute this data to all 10, 11 employees or 10 employees, 10 GB each, right? But there is one greedy person who took all the resources. This, so you want to control that. And that is also something that Kubernetes helps you to do it. So you basically can say that don't use more than a specific RAM and CPU in your resource. So maybe doing that tracking and another every piece of code basically can have their own limitation. In our examples, we had payment. Now payment might be a big API because it has so much of complexities around security and stuff. Whereas the add to cart is a small piece of software. So the computing required by payment might be higher as compared to add to cart. So of course, that's how you're going to define it in your code as well, saying that, okay, at any point of time, one instance of add to cart can take 2 gigs of RAM, but and let's say 8 CPUs, but but at the same time, the payment API might need 6 gigs of RAM and then 16 CPUs. So you can do that kind of definition. So a question came in. So Kubernetes will replicate the number of Docker images that required? Yes. That's the role of Kubernetes, that it's going to replicate the number of images that you require. So if you just provide one image and you say that I need 200 instances of this image, and Kubernetes will spin it up in a minute. That's the beauty of Kubernetes. What is the difference between monitoring and health check? So monitoring basically is for you to monitor how everything is working. Like health check is an automated probe. So let's say from a manager perspective. Now, as I'm the manager or head of a department, I have to showcase some sort of a progress and reports to my managers or my C-level. Right, so that is monitoring. So monitoring will be done by my bosses to make sure that everything in my department is working fine. Whereas health check is basically an employee, me checking with my employee whether they're able to work or not. So monitoring will give you the capability of monitoring all the resources at a glance and then put some sort of alerting on it, whether something is consuming more resources, in another example, whether we have the right number of resources as we need or not, whether we are performing in a right way or not, right? Maybe we are consuming tens and 100 gigs of RAM, but the application is still slow. So that comes under monitoring. Whereas health check is to make sure whether is an employee is able to work or not. So whether an image, whether an instance is working or not. Then rolling updates. The idea of a rolling update is that that let's say if I develop a new version of the application, I don't want to push this new version of the application to all the users at once. I want to test it out on a specific set of users. That's also possible that we say that, okay, uh, check it on out of 100 people, check it on 10 people. Sorry. If all these 10 people are happy, if we are not getting errors on these 10 people, then increase it to 20. Then if 20 are happy, then increase it to 50. If 50 are happy, then increase it to 100. Instead of directly sending it to 100 people and seeing, okay, that something is not working. all these companies basically, let's say Facebook, if Facebook is introducing a new feature where when you click on this like button, a sound coming, haha, or when you click on when you basically use this haha emoji, haha as the sound also comes in, right? So they don't want to push it to all the people at once. They will send it to a limited set of users, and then basically, if they are getting the right feedback from those users, then they will send it to more and more and more. Otherwise, what you see is a backlash if that feature has any bug, if that feature has any issue. So Kubernetes basically allows you to do those all kind of updates and deployments and stuff. Um, we are running out of time, but I will like to go through basic concept. I also wanted to do a demo for you, but based on the questions, I understood that I want to cover more basics as compared to a high-end demo. So I'm focusing on that right now. But you need to understand some of the fundamental units of Kubernetes. We talked about node. So node is nothing but a virtual machine. Now, when you talk about Kubernetes cluster, you don't need one server. You need group of servers which can run these workloads for you. And one individual server is called node in the terminology. Um, then, then this master basically tells communicate to all these nodes. I'm sorry, guys, I'm not keeping well. Sorry about that. So master basically tells this node on how to communicate, and we said that okay, we need to have this kubelet installed on these nodes to make sure that master can talk to these individual servers. Then then comes something called as pod. So pod is nothing but a basic unit of deployment in Kubernetes. So what does it mean? We talked about these individual APIs, right? The tracking API, for example. Now, what all do you need to run this tracking API? This tracking API, let's say, is built on .NET framework. So .NET is one layer of container that you need. Then, then you need that piece of software and the dependencies of that application, the code that you have developed for tracking, right? Where you basically can see where is your package. So that piece of code needs to be deployed, and the underlying dependency needs to be deployed. So from that perspective, um, you can see that it's one individual unit that is needed from you will basically see as one individual unit that you can deploy and run. So pod is then nothing but a group of containers. I'm getting some of the lovely messages. Thank you, guys. I don't have water with me. I might have to go out and then fill in the water in my water. So don't worry, I can manage for another 5-10 minutes. Thanks for your lovely messages, though. So containers are nothing but pod is nothing but a group of container. In our example, as I'm based out of Germany right now, and there's been some rains going on over here, and the weather has changed drastically. That's why I'm like sick. I've been feverish, but I can manage. Thank you. So coming back to this containers stuff, that a pod is nothing but a group of containers where this container, one container can be the .NET framework, another can be the libraries, another can be the actual application that you have developed. But they can run together as one piece of software because you're running this tracking API as an individual software, right? So it's a group of container that you need to run one single entity. And I saw this message whether pod runs on node. The answer is yes. The node is the actual computing required underneath the actual servers, whereas pod is the individual services that we are running. And every container can have its own configuration. So .NET runtime can have its own configuration. The application has its own configuration as well. So a pod can has one or more containers. For example, a server, the application, any cache that you might have to run that pod. So it's one application that we need to run. All of them, all the containers inside a pod are scheduled together, and we guarantee that it will be on the same node because it's one single unit, right? It's packaged and deployed as one entity. So of course it will be in one node. It's not going to happen that that one container of a pod is in another node and other containers on the node in another node. So this is never going to happen because it's going to be as a single entity. It's going to be all packaged together into one node. And and every pod has its own IP address. So it's an internal IP that you have assigned to all these pods. This is where Kubernetes know. Um, so I received this message from Suzanne. So Docker inside node and nodes inside pods. No. So Docker inside pod and pod inside nodes. So think of it that think of it that the the pod is running with multiple Docker images in it. One image is .NET framework, another is your application framework, then at the actual piece of code. These are different Docker, different images. And when you deploy it, you get an IP address. Now, when I say 200 instances, I mean 200 instances of pods. Now, these 200 instance of for this tracking API is distributed across multiple nodes. So that if one node goes down, one server goes down, it's not that the whole application or the whole tracking functionality goes down. It's to be distributed across multiple nodes. But all these three things are packaged together and and then that they will have its own IP address. And that's how Kubernetes basically sends a request to these individual IP address. For you don't have to do anything. Kubernetes is smart enough to do that for you. Then we have a concept of replica set. So in our example, we said that okay, we need 200 instances of this tracking API, right? So Kubernetes basically, here we say that in this example, we are saying instead of 200, I'm saying three. That I need three instances of this API, this pod, and A, B, C. So replica set will make sure that we have three instances of it running. Then you can also specify some of the things like that. Okay, if the traffic is high, then increase it to 10, but don't increase more than 10. Minimum at any point of time, you have three running. So let's say if one goes down, if if the third one goes down, Kubernetes see that okay, this one has crashed for some reason, and it will be replaced automatically. So instead of C, it will be replaced by 3, but replica set will make sure that we have n number of instances running at any point of time. Then we have the concept of deployment. So deployment is basically, um, in a very simple words, it's basically a piece of code which helps you to deploy the application. Um, and then you can have different apps, different replica set, replica set, and different settings on this. Um, then the individual services, we talk about the deployment, packaging, all of these together, but individual services are the services like tracking API. So let's say your tracking API is running on these three different ports and you have this IP address assigned to it, 1096 to 1096 1096. It should be four. It's a long copy paste example for me, but I will fix it. Um, so you will not you will not access as a user these pods directly. You will access it via a service. So you will say that create a service where role is equal to web. In our example, we can say where role is equal to tracking API. And then wherever the tracking is running, then that will be served via a service to it. And um, underneath Kubernetes will make sure that it can send traffic to these individual pods. Then the whole concept of services is that services are only consumable within the cluster. So you should not expose these services out. There are some ways of exposing it out with the load balancers as well, but you don't expose it out directly. You expose it with a concept called ingress. So if you want to consume this services internally, then you then have to expose it. For example, if there is any internal service which you want to use, but the users are not directly using it, it's basically used by some of the services that we are running. So let's say your front end is consumed by the application where you see the UI is consumed by the users, but there is something internal, something to calculate the discount, for example, is an internal service in our Amazon.com example. When you put a discount coupon, right, that API does not have to be exposed out. So it has to be consumed within that application itself, within the cluster. So that can be exposed as service, but that UI has to be consumed by the users directly. So you expose it via something called as ingress. So ingress basically helps you to make sure you manage these in a more secure and manageable way, if I have to put it out in one line. So going back on the Kubernetes architecture, that we have this Kubernetes master who is responsible for managing these in different worker nodes. And these worker nodes can be one or two or multiple in the cluster, depends on the size of the cluster. And then you have individual containers running. And these different pods can run different kind of services. This pod 1 can be tracking. This pod 2 can be add to cart. This pod 3 can be billing. And then they can have one or more containers inside this pod, but pod is the individual component of individual unit that we can run. And and then we have Docker and Kubernetes. So basically Docker engine and Kubernetes is one engine which basically helps you to communicate it to these worker nodes. Yes, it sounds complicated, and it is complicated. It's not easy, but if you understood even 60% of the concepts today, I think I'm happy with it. If you start looking into it and if you start doing some practical, this is when you will have this light bulb moment, that you wake a moment where you understand the whole concepts clearly. So we'll have some demo as well where I had some demo, but I'm not going to do it now because we have run out of time. But the whole idea of that demo was basically that you can create you can basically create a project and then push it to a container registry and then push it to a Kubernetes services under that. Okay, I am open for questions now. I've been answering some questions. Should a container inside the pod be same replica or they can have different images too? Let me understand this question. Should containers inside the pod be same replica? No. So inside the pod is one replica. Now what you say is one replica is the is one pod is one individual unit which can serve you these requests. Then you have when you say replica set, you say that okay, I need at least X amount of units of this one. I know if one goes down, the another one basically takes over. Sorry. Ingress is deal with you proxy. To some extent, yeah, but it will go into a deeper concept. I don't want to touch on that right now. Just wanted to ask how if an API container service needs exposed to external. That's a good question. So if you want to expose a service out, right, then you basically first expose it with ingress. So you put up an ingress on top of your services, and then you basically don't directly consume via ingress as well. You put some sort of a firewall or a gateway on top of it. So in the Azure world, we have app gateway, and now there is something called app gateway for containers, which was introduced 6 months, 8 months back. So it gives you a flexibility where the actual calls from the internet goes to this gateway, then to Kubernetes, and then Kubernetes basically handles it behind the scene. But it's all exposed via ingress to this gateway, and gateway is your entry source of the application. And then you have a lot of security considerations from DevSecOps point of view. You make sure that you expose it in a wide way, you configure it correctly, you have the wide vulnerability checks on these images that you're using, your cluster is secure, so on and so forth. Um, any more questions? I'm getting some regular questions about a demo session. Maybe we'll sync up Chaitanya internally and then we'll come back to you about it, but we don't have anything planned as of now. Um, yes, I can share the link with you guys. Janushant has asked for a basic project. I can share the link. Then someone has also asked about reaching out to me. So yes, I'm available on LinkedIn. I can share my email address as well as you guys are asking. But the easiest way to reach out to me will be on LinkedIn. Connect to me on LinkedIn and drop your message. I will be happy to answer any queries, any question that you might have. But I've also put my email address in the chat. Any more questions? Nope. So we are out of time, 8 minutes over time. So I would like to thank all of you to be patient with my stuff as well, and also with my content. And thank you, Chaitanya, as well for organizing this and calling me in
So
here as well.
thank you, Mohit. Thank you so much for taking your time in guiding us today about this wonderful topic, Docker and Kubernetes. And we could see that you were really unwell. Despite that, you guided us so wonderfully, and we really appreciate all the efforts that you have given for this session. And I'm sure everyone had a great learning experience. The way you gave examples and the way you taught, I mean, it was really wonderful. And we hope that you get well soon, as early as possible. I mean, so we really hope that. And please do take care of yourself, like have medicine. These are some of the comments that I was also reading in the chat box, and they were like worried about the like you were having difficulty in speaking, so they were worried about you, and they were saying like just end this session quickly so that they can also like you can also rest. So that was a gesture from the community, and really thanks for all the efforts that you have put for this session.
Thanks everyone. Thanks for joining. And yep, please reach out if you have any questions. And we might plan for a sequel on this one.
Definitely, like we look forward to have you in the upcoming sessions as well, and we will definitely plan something for this for Docker and Kubernetes, a practical or something. And really, like once again, thank you and really appreciate your efforts.
Thanks Chaitanya, and thanks everyone.
Yeah, and do connect with Mohit on LinkedIn and do share your feedback with him. If there's anything that he can improve, if there's anything that we can improve, do share about that on his LinkedIn. And if the how was the session, just anything that you feel like any topic that you feel like we should cover in the future, anything that you can feel like he can help you with, just you can feel free to ask your doubts with him either on LinkedIn or on email ID. Yeah. So we look forward to have you all in the upcoming sessions as well. And I'll share the feedback form with you. You can fill out the feedback form and you will receive the certificate for participation for this session. And yeah, just give me a minute. I'll share the feedback form. So yeah, Mohit has shared his LinkedIn with us. So do connect with him. Do reach out with him. And thank you so much, Mohit.
Thank you for having me. Thanks everyone. Bye.
Bye. Take care. And get well soon. Yeah, so I am sharing the form. Just give me a minute. So everyone, please don't ask again and again for the form, for the feedback form. Like, I know you are here for the certificate. You really like getting some reward for participation, but or like a certificate form. I mean certificate and feedback form. Plus, please don't ask again and again in between the sessions, because this is something that it sometimes disturb our speakers. Like, they are, the flow gets break every time. It's in our agenda that we share the certificate form in the end of the session. So if the session is 1 hour long, then don't just ask for the certificate in just after 10 minutes of the session. So this is something that I would really appreciate you guys if you follow this. And uh, so I'm one developer. So we don't have any openings right now in our organization, but if there will be any opening in the organization that we might know, like they are hiring, we will share that opportunity in the community. So do join our community on WhatsApp and on Discord. And I mean, if you are not on Discord, then you can join it on WhatsApp. And yeah, so I have shared the feedback form with you guys. If you fill the feedback form, you will receive the certificate. So right now we don't have, like I said, we don't have any opening. And